So before we start, let me remind you next week is case study. So for case study, it's important for if you're distant learning students, let me know by the end of Friday this week, 22nd, whether you will choose to participate in person in class or live through BlueJeans or outside of the class participation time. And then check syllabus to see what you need to prepare for each option. So basically, if you want to participate live, then you don't need to submit anything before the class time. If you choose to participate outside of the class time, then you're required to submit your answers to the case study questions before 9 p.m. of next Tuesday. And I'll post the instructions through announcement. And the case study material and case questions will also be available tonight. Let's see. So next class, the main structure is we're going to spend a little time in the beginning, go through the case, but make sure that you read through the case beforehand so you can catch up quickly. We're not going to just spend a lot of time read word by word through the case study. So, and then we're going to break into group discussion, and the groups will be assigned to you, and I should be able to let you know your group assignment by Monday. And then at the end of the group discussion, you can formulate your questions, your answers to the case study questions as a group and then submit it to me. Following that are whole class discussions, and each person's contribution will be counted individually. After class, submit a brief reflection of what you have learned throughout the discussion. And then also to facilitate discussion, also for me to track who's responded and how many times, I will also post instruction of using name card. So you'll be able to use a template to make your name card, so I know your names, and when I call you, I can register your participation. Okay, so any questions? If not, let's start today's discussion. So previously, last week we talked about aggregate planning, right? So how to use aggregate plan to maximize supply chain profits. And today, we're going to build on aggregation planning and expand the scope of planning to beyond the aggregate plan of a single company and to the supply chain. And especially when there is variability in predictable demand. So, especially we're going to talk about how do we manage supply side and demand side in order to synchronize the supply chain when we're facing predictable variability. And when we're facing with variability, how do we use sales and operational planning to maximize profitability? So our focus is within the realm of predictable variability. So basically, the variability that's embedded in your forecast. Right? So, for example, if you forecasted there's going to be seasonality, you perceive that there's going to be demand peak in April and demand valley in December. That's what we talk about, what we refer to by variability in this chapter's discussion. So, of course, variability are generally not desirable, right? We tend to dislike variability because it creates additional challenges for us to match supply with demand. And we talked about several reasons when during last week's class when we discussed aggregate planning. So in general, higher variability, no matter it's predictable or not predictable, will lead to increased cost and reduced responsiveness in the supply chain. Now, supply chain demand and supply management and operations planning can significantly improve the performance when applied to predictable variable products. And the way we achieve that is through two broad options. One is to manage the supply, the capacity, inventory, contracting, subcontracting, and backlogs. And the other one is to manage the other side of the story, which is demand. So, for example, in last class we talked about the example of red tomato. Right, so if you remember, red tomato sells gardening tools, which has a peak in April when spring comes, and the valley is about January. Right, so now this is predictable variability in demand. And what are the options for red tomato to deal with this predictable variability? So in last class, we actually already talked about some strategies, right? So we talked about certain strategies associated with aggregate planning, which are what? Chase strategy. Flexible. Level strategy. So, in essence, chase strategy is we fix the capacity, right, and then fix inventory to minimum, and then chase the demand by varying capacity. And the other one is we keep the capacity level. The other extreme is keeping capacity level and build inventory ahead of peak demand in order to satisfy peak demand. So for one, if we carry minimum inventory using chase strategy, what are the advantages of that plan? Avoid shortages. Okay, so shortage cost is low. Anything else? So in that case, we're varying capacity, right? And keeping what's low? Inventory low. So then the associated inventory cost should be low, right? What are the disadvantages?
Economy of scale.
Okay.
Less inventory. Less inventory.
Less inventory is an advantage, right? What about disadvantage?
Responsibility.
Responsiveness. How so?
Very price.
High ordering cost. Because we have to order again and again to chase the demand. Chase the inventory.
So we're not sure if order frequency would be increased. The difference is now production quantity in each period would be highly variable. Right? In order for us to achieve that, in order to match, say, demand in the peak period completely, which that means we need to build capacity enough to cover the peak demand. Right? So in that sense, you need to build a very high capacity. Then in the low demand period, there's a lot of underutilization. Exactly. Okay, so the other side is build inventory ahead of time. Right, so what's the advantage of that strategy? Uh-huh.
No shortages. Obviously no shortages.
Possibly. So, but if we assume that we know demand ahead of time completely, then that's not a concern.
Economy of scale, ordering, batching.
That's also depends. So these two strategies are on two ends in terms of managing supply, right? One is keeping capacity fixed and vary inventory. The other one is keeping inventory sort of fixed or minimum and vary capacity. And their advantages and disadvantages are basically exact opposite. Right, so one is minimizing capacity investments but have high inventory cost. And the other one is minimize inventory investments but high capacity cost. So the other approach, which we didn't quite discuss in last week's lecture, is managing the demand side. So how do you think we can manage demand?
We have excess inventory, we can put sales.
Sales, yes, through sales promotions. Okay, so what's the advantage of sales and promotions?
Reduce inventory, save cost. Inventory holding.
Reduce inventory holding cost because of what?
Because of selling the cheap.
Essentially, by introducing promotions and sales at appropriate times, what we're trying to do is to reduce variability in demand. All right, so then the question is that now we have these options, which one is the best strategy? And Additionally, when we're doing price promotions, when is the best time to promote and by what amount? So some of the specific strategies of managing the supply and demand side. So managing supply side, the two main levers we discussed are capacity and inventory. So to manage capacity, one is we can introduce flexibility in the time of workforce. So this is achieved by, for example, using the 2-shift schedule, and then the rest 8 hours in a day can be scheduled as overtime if there is a peak in demand. Additionally, we can use seasonal workforce. So when demand is peaking, then we hire more people, or we hire some part-time workers. So this is, for example, very popular practice in tourism industry. So there we have full-time workers that work year-round, but in peak tourism time, then we hire seasonal workers. And this could be challenging to achieve if there is a highly constrained workforce available. And then the capacity the facility itself can be flexible. So basically, we can acquire machines and facilities that are capable of processing different types of products. So for instance, if a company that sells products 1 through 10, then each product may have their dedicated capacity to basically so let's say this is our base demand, but there is sometimes demand peaks, right? So managing capacity is basically how do we deal with these extra peak demand? How do we supply these parts? So by using dual facilities, what we usually do is differentiate the facilities by specialized facility and flexible facility. Right? So in the baseline part, we use specialized facility because they're usually more economical to produce a unit of product, and we use them to produce products 1 through 10, each capable of producing one single type of product. And then when demand peaks, then maybe we're not so sure how much demand peak is for each type of product. Then we use flexible facility to accommodate some peaks for uncertain type of product. And then, of course, subcontracting is an important tool. So one example is power companies. So now, utility companies, they don't generate the full electricity usage for everybody. When there is a peak in utility demand, the power company often buys from local microgrids to supplement the demand. And then the production lines can also be designed to accommodate for product flexibility. So one is a production line configuration that can accommodate different number of workers on the line. So by varying the number of workers, you can change the production rate of the line. And the other one is by having just purely flexible machinery. Then, just like the dual facility idea, by assigning flexible machines to either product, we can increase the production rate of that product. So in terms of managing inventory, one very popular approach is to use common components. So this is the idea of variability pooling. Right? So if we have demand that are sort of independent or negatively correlating with each other, then adding their demand together can cancel out the variability. So, of course, that wouldn't work if we have demand that are perfectly correlated with each other. So demands that are exactly, the same have exactly the same ups and downs, then adding them together would not reduce variability. So in that case, what we do is differentiate inventory for predictable demand products with unpredictable demand products. So for predictable demand, we can build seasonal inventory ahead of demand peaks because there are little changes that we expect during the production lead time. For unpredictable demand products, we try to produce as close to the demand timing as possible. So the inventory capacity are two ends of the managing supply. So trading of the cost for capacity and the cost for inventory. The leveling capacity strategy will lead to a lot of inventory, and then the low inventory strategy will necessitate high investment in capacity. So then we come to managing demand side. So now we know we can often influence demand by changing the price of the product. So, if we offer a discount to purchase during the off season, then we have an opportunity to move some of the peak demand to off season. And that's our goal. The goal is to flatten out the demand curve, reduce variability. And in doing that, it's very important for us to understand how does price promotions affect demand. Right, so generally, reducing price will tend to increase demand, at least during the promotion time. But how does it increase demand? And from where is the demand coming from? Depends on the scenario. So in the first scenario, the increased demand is from actually market growth. So, for example, take, say, we're trying to sell Toyota Camry. Then the market growth demand increase is the increase in the actual consumption of the product from either new customers or existing customers. So, for example, in market growth, so maybe we're attracting additional customers who either did not want to buy a car initially, or maybe customers who were was planning to buy a lower model. So in either case, the total sales of Toyota Camry would increase. Right. The second reason is stealing share from competitors. So basically in that case, an example is, people who initially plan to purchase from Ford decided to purchase Toyota Camry instead. And then the third one is forward buying. So that's just shifting the demand from a different time to current time. And so in this case, it will be shifting people who were planning to buy a Toyota Camry 3 months down the line to purchasing it now. So depending on what the reason for increased demand, the planning of the promotion would have different strategies. So particularly it would influence the timing of promotion. So how do we decide timing of a promotion? First, it's influenced by the impact on demand. So whether it's from the first or second or third reason. And it also depends on cost factors such as the cost of holding inventory, the cost of changing capacity, and the profit margin. Okay, so now let's think through how does each factor impact when we're going to implement promotion. So basically, let's make the case simple. So we have a seasonal demand product, and the option is to either promote during the off season or promote during the peak season. Okay. Okay, so now, given the different factors here, let's see, does each factor make us more inclined towards promoting off-season or peak season? So the first factor is there's high forward buying. So a lot of people would tend to, a lot of the increased demand is due to forward buying instead of the other two reasons. In that case, should we tend to promote during a low demand or peak demand period?
Big demand.
Big. Low demand. Low demand.
Okay. For people who say low demand, explain.
If we like, suppose if that month when the demand is high, suppose that is the Christmas time where people buy cars, suppose. So instead of promoting at the time of Christmas, it is better to promote them early, so that the sales, those who are planning to buy it forward, they buy it beforehand, before the peak period comes.
Mm-hmm.
So promotion before the peak period comes, that is the good factor.
Right. So, a line of thinking to decide when to promote depends on two factors. One is the impact on our revenue, the other is an impact on the cost. Right, so increasing revenue will improve our profits, and reduction in cost will also improve profits. But each of these factors will determine how these two compare in relation to each other. If there is a high forward buying, that means what?
You have to top up the inventory.
We'll be very effective in smoothing out the demand by introducing promotion during which period? The off period. So basically the reduction in cost due to demand variability will be reduced significantly. What about high ability steel market share?
High. When the demand is high,
When demand is high, why?
because every other competitor is trying to sell at that point of time.
To beat the
So if we
competition.
give more promotions, the customers come to us.
Yeah, so when there are more customers on the market, it's more effective for us to steal them over to our side. Alright, so this is peak. High ability to increase overall market. Also peak for the same reason. High margin. Peak. Because what?
Sales.
More
Higher
sales.
margin, higher revenue, higher profits.
Right. So in this case, improving revenue is more effective, and improving more revenue is more effective when there is more demand. So low margin, on the other hand, would be off peak. High manufacturer holding cost. Off season.
Yeah.
Why is that?
To reduce the inventory holding cost.
Reduce inventory cost. High cost of changing capacity.
Peak season.
Peak
Because
season?
You're expecting more demand during the peak season. So
right? So what does that do to the cost of changing capacity? Right, so we should reduce the need to change capacity, right? And we do that by flattening out the demand. So again, off season. So high retailer holding cost. So if there's forward buying at the retailer, what does that do to the retailer's inventory? Increases retailer inventory. So if the retailer holding cost is high, do we want that happen or not? No, we don't want that to happen, right? So we should tend to put promotion on peak season, or don't do promotions. What if there is a high promotion elasticity of consumer? So basically, promotion elasticity means that by changing the price a little bit, we can see the demand change a lot.
That will be for
Off season. So basically, that just reduces the amount we need to discount the price for. All right. So now let's look back to the case of green tomato. But now, in the previous case of aggregate planning, green tomato is only doing the planning for its own company, right? So now, not green tomato, red tomato. Red tomato is not directly facing customers, right? So it's a manufacturer, and it has to work with a retailer to distribute its product to end customers. So it decides to work with a retailer called Green Thumb to distribute the product. Now, the cost parameters are exactly the same as what we had before. And the demand is going to peak in the spring season and valley in January. So red tomato and green thumb need to design a way to collaborate between one another to determine their promotion period. So basically they want to explore how does the timing of promotion affect their profitability. So initially they have a disagreement between Green Thumb and Red Tomato. Green Thumb wants to promote during the peak period because it improves sales and revenue more. And Red Tomato, of course, want to promote during the off-peak period because that reduces their production cost. So let's now see what is the optimal approach. Okay, so this is basically what we had in last class. So this is the aggregate plan, right? So we're choosing these decisions, the hiring, laying off decision, workforce, overtime, inventory, subcontracting, and production decisions to minimize the total cost of the aggregate plan. And now the added decision is promotion. So this is registered here. So this cell is 0 if we're not promoting at all, and is equal to 1 if we are promoting. And this cell says which month are we promoting, right? So what we want to compare are the peak and off-peak months. So either month 1 or month 4. So in the original case, we had no promotion, and we calculated the total cost for the whole manufacturing aggregate plan to be $422,660. Now we're trying to decide promotion timing to maximize profit. So which means we also need to calculate revenue. And revenue is price times demand. Let's say the base price of each tool is $40. And demand, so this is the demand given by our previous example. Peaking in month 4 and lowest in month 1. And say the promotion is simply reducing the selling price from $40 to $39. So $1 discount. And this, of course, will have different implications on the demand in various periods. So these effects are specified here. So here it says the consumption effect, so which is basically our market increase or share steal factors. Right, so this is saying for each dollar we decrease the price by, the demand in each period will increase by 10%. So this is, of course, established through some price demand analysis. And forward buying parameter suggests that in if we promote during a certain month, then the 20% of the demand from the next 2 months will be shifted to the current month. Okay, so of course this has also to be should be based on some previous analysis. And we assume marketing has already established these parameters for us, and we'll look at different scenarios. But let's say these are our input information right now. And then you can see here. So the price side depends on what is the base price, whether we're promoting, and whether the current month is under promotion. Right, so if there is a promotion and the promotion is the current month, then we have $39. Otherwise, it's $40. Okay, so this is a combination of two if logic. So now if I say I do promotion and I do it in month 4, then month 4 price becomes 39. The other ones don't change. If I say I do it in month 1, then 39 becomes first month price. Then we have demand side. So demand depends on the base demand, which is given in this table here. And also, is there a promotion in the current period? And what is the consumption parameter and what is the forward buying parameter? Alright, so in this case, the demand for January is equal to initially January demand is 1600, and because there is a promotion in January, so we have a consumption increase effect. So we multiply this by 1.1 plus the forward buying portion, which is 0.2 multiplied by the total demand of February and March, which is 3,000 plus 3,200, and that will give you 3,000 demand. Okay, so now imagine you're first collaborating between Red Tomato and Green Thumb to come up with a promotion strategy. Given the promotion strategy, Red Tomato will then set its own aggregate plan. So in that case, what it means is we need to, based on this plan, we need to solve the aggregate plan again. So if we solve this, we get a solution. So you can see the total cost becomes 422,080. Now total cost is slightly lower than before. The total revenue is higher than before, and the total profit has also increased from the previous case. Now, then we can look at, so now comparing to the previous case, if we did not promote, you can see the inventory has reduced in the one with January promotion. And the total cost reduced and profit increased. So January promotion is a good idea, but is it as good idea as promoting in February? If we promote in February, you can see demand is much more variable than promoting in January. So what's the effect on our aggregate plan and the total profit? So now the total revenue has indeed increased because of the increased demand during the peak period, but the total costs also increased. And the total profit is slightly lower than promoting in January. Alright, so comparing between these two strategies, it will be best for us to promote in January. Now, question, what if the two companies did not work together? What if Green Thumb plans the promotion by itself? What would Green Thumb do?
Promote when the entry is high, when the demand is high.
Promote when demand is high. Why?
Gain more sales at that point of time.
Mm-hmm. So what would their goal be?
Reduce inventory.
That will
Reduce
Like the
inventory.
market growth. That
Sell as much as possible. They don't care about capacity and everything. They just want to make the product.
Sell as much as possible. So basically maximize revenue, right? So between the three scenarios, the promoting in April one has the highest revenue, but also it has the highest cost, which is what the manufacturer cares about. So without collaborating on this promotion plan, we can actually generate a strategy that hurts the total supply chain. And the fact that we're able to do this analysis is by assuming that these two companies are working together. So the importance of collaborative sales and operations plan process is also supported by that the optimal action is different if most of the demand increase come from the market growth or stealing market share rather than from forward buying. So, for example, let's say we change the parameters. Right? So we now increase the consumption increase part from 0.1 to 1. Then we can see, so what that does is it increase the effect of on revenue or cost. Revenue. right? So, which means which strategy would be better?
Increase high cost, high peak period.
High promoting in peak time. So let's see if that's the case. So with promotion in month 4, the total revenue is 783,520. If we promote in month 1, oops. So total revenue reduced. Total profit is 242,680 in month 1, and in 4 was 247. Okay, so indeed now with the consumption effect so high, the impact on revenue exceeds the impact on cost, so favors promotion during peak demand. All right, so you can also look at other scenarios. For example, change the base price, in our slides. So we can look at these all these different scenarios. So the regular price, whether it's $40 or $31. Right, so when price is $31, what do you expect the optimal strategy will be?
High period.
So you can simply compare these 3 numbers, right? The highest number is promoting in January. And comparing this, so promoting in January is optimal for regular price is $31, and these given percentage parameters. So this corresponding to these percentage parameters, this case, right, the better one is April. So the difference here is because of what? How come change the regular price, change the best strategy?
Base price. Profit margin.
Profit margin, yes. So high profit margin would tend to favor the high peak promotion, and low profit margin, the low peak, low demand promotion. Okay, so in promotion planning, we're basically trading off the impact of promotion in either low demand periods or high demand periods on the effect on revenue versus cost. and the average inventory will increase if we run the promotion in the peak period and decrease if promotion is run off during the off-peak period. But promoting during peak demand will increase the revenue of the plan, and at the same time lead to significant fraction of the demand in forward buying. And the profit margin, if profit margin declines, then off-peak demand promotion becomes less profitable. In general, when we face seasonal demand or demand with predictable variability, we're use a combination of aggregate plan, so deciding the capacity and inventory strategy together with price promotions to maximize supply chain profitability. And the best scenario is for the entire supply chain to work together to achieve this goal. But in reality, it's oftentimes very challenging to get the entire supply chain to work together. So some practical approach is to form these joint teams between different supply chain members. And these teams will ensure that the incentives for the supply chain members are aligned. And also, practically, because the collaboration is difficult and the payoff from collaboration is very significant, it often requires very high-level executive support to guarantee that the supply chain interests are the collaboration is devoted with sufficient resources to guarantee that the competing interests are resolved. And finally, if there is a change in either the demand or the supply circumstances, the reality could deviate from the plan. So there should be an early warning system built in the S&OP process to alert the planners to provide new plans to account for these changes. Questions? Okay, let's take a break. All right, so now we talked about matching supply with demand in terms of a single company, and then in terms of sales and operations planning between different companies in the supply chain. Now we go a step forward to look at general coordination strategies between different companies in the supply chain. So first of all, we're going to describe what is supply chain coordination, and then what are the common obstacles for achieving coordination, then how do we use some managerial levels to overcome these obstacles, and finally some practical approaches. So far have already experienced firsthand some of the most detrimental effect of lack of supply chain coordination, especially through our beer game simulation. So in supply chain coordination, the ideal case is everybody are taking actions that are consistent with each other to achieve aligned goals, which is to improve total supply chain surplus. And this is difficult because different stages and different companies in the supply chain can often have conflicting objectives. If their own company is trying to maximize its own profits or its own benefits, and if their objectives are not properly aligned, they often can take actions that hurts the overall supply chain profit. So in order to achieve coordination, we have to make sure that the stages are communicating and sharing information, and also considering what their actions are affecting other companies in the supply chain. And this is not easy, of course. So, for example, Ford Company, in terms of their first tier supplier alone, they have over 1,000 suppliers, right? So now, in order to make sure all of these suppliers' objectives are aligned, and among them and with Ford, they have to share information with all these suppliers and make sure these suppliers share their information with their own suppliers. So along this path, oftentimes we see information gets distorted and people make decisions that hurt others' performances and hurt the overall supply chain. And so the two common reasons for lacking coordination is the conflict between stages' objectives, and the other one is information delay and information distortion. So when there is a lack of coordination, what do we see in the supply chain? Bullwhip effect, yes. And of course, associated disbenefits of that coordination. So bullwhip effect, you don't need further introduction. So basically, as we move up the supply chain, we see the order sizes variability increase significantly, and the demand information gets distorted further and further as we move up the chain, and the total supply chain profit gets lost, total supply chain costs are increased, and demand are not met, and so on and so forth. Now, lack of coordination generally will increase various kinds of variability, and which will hurt supply chain surplus. So this variability can be predictable variability and uncertain variability. And variability overall can have very detrimental effects. So having more variability will increase the cost involved in managing supply chains. So, well, first of all, right, having variability leads to higher manufacturing costs and higher inventory costs because of one, the cost of varying manufacturing capacity. The other one is the need to carry more and more inventory. And variability also will make scheduling more difficult. So, and there are times when available capacity and inventory cannot immediately satisfy demand, and that will lead to longer production lead times. Right, so replenishment lead time also tend to increase with lack of coordination. And lack of coordination also increases the requirement on transportation. So because transportation need also fluctuates over time, so we need to maybe adjust the transportation capacity from time to time, which leads to either waste of transportation capacity or the cost to adjust our transportation capacity. And the labor requirement associated with shipping and receiving at different stages in the supply chain will also fluctuate with our orders. And we can, when we have less coordination, we respond by either carrying excess labor capacity or we change labor capacity from time to time in response to the fluctuation, both of which will lead to higher labor cost. And of course, increasing variability will decrease our ability to match supply chain supply with demand. So overall, the product availability will reduce. And because of the increase in cost and the loss in demand, meeting demand, we lose on profitability of the chain. So when there is a lack of coordination, we know little about each other in a supply chain, and there is a tendency, as you saw in beer game, to blame each other for the poor performance. So this can lead to a lack of trust among different stages and exacerbates the effects, the efforts to coordinate. So in summary, if there's a lack of coordination, it can hurt the responsiveness of the supply chain and increase the cost of the supply chain and reduce product availability as well. Now, so basically, any factors that can lead to either localization of decision making or an increase in delay of information or distortion of information, or the variability within the supply chain is going to present obstacles to coordinate. And these obstacles can come from incentive issues, can come from the processing of information, can come from different operations and pricing as well as behaviors of supply chain members. So incentive is a big part of supply chain coordination. So basically, there is no natural way of making sure everybody is going to just initially try to maximize supply chain profit overall. Right? Everybody will still care about what they get in the end. So in times when their benefits are not aligned with one another, that could lead to actions that increase supply chain variability and reduce profit. So, for example, one is the local optimization. Whether it's localizing within each function in the supply chain or each stage within the supply chain. For example, if the compensation for the transportation department is linked to transportation cost, then we're going to see transportation make decisions that tend to decrease the units cost of transportation. And that has an impact on inventory systems as well, right? Now, if we want to always fill a truckload, that means each time we order a lot. That will lead to potentially more inventory. And then another classic example is promotion, right? What we just saw in the Red Tomato and Green Thumb story. If Red Tomato acts on its own benefit to improve, to reduce its costs, that will lead to an action. If Green Thumb tried to maximize revenue, that would lead to another action. And these actions could potentially conflict with what's best for the supply chain. Another obstacle for in terms of incentive is associated with sales force. So traditionally in a lot of companies, sales force get promotions or bonus depending on how many sales they make during a certain selling period. So oftentimes this is the number of sales during a promotion period. So if that's the incentive, what would that lead us to? So all I care about is the total sales in, say, this month where the promotion is going. So if I'm a salesperson of a manufacturer and selling to a retailer, then the salesperson is highly incentive to convince the retailer to buy as much as possible during this period. So a strategy to do that is to say providing quantity discount for large purchase in this month, right? And then the retailer, even though they don't need to buy that much, will generate a large order, and then the salesperson will get the bonus or the promotion. So how does that affect the demand of the manufacturer? Increase the variability, right? So we're basically artificially creating this peak in the manufacturer's demand. So inappropriate sales force incentive will lead to higher variability and of course reduce supply chain profit. The second obstacle relates to information processing. So as you saw in beer game, in the first game, when we don't share information between different parties, as the demand information travels up the supply chain, it gets more and more distorted. And the result is the suppliers will order in higher variability than the retailer. So one reason for that to happen is because each parties in the supply chain are making forecasts based on the actual orders placed, but not the final product demand. And each stage will not understand they are working together as a total entity to fulfill end customer demand, but see their individual roles as fulfilling the immediate demand. So their production and orders will base on the forecast of this immediate production orders, and this will get more and more distorted as we move up the chain. And this, of course, is made worse by the lack of information sharing. So this happens not only in ordering, but also in collaboration between different functions. Right, so planning a promotion is if there's a disconnection between manufacturing and sales, then the retailer or the sales could increase the size of a particular order due to the promotion, and that has implications on the manufacturing department. And then there are operational obstacles. So operational obstacles relates to placing orders or fulfilling orders, and this is more and more difficult as the variability increases. So when there is a lack of coordination, one potential harmful effect is that companies would order in very large lots. And usually this is due to an effort to try to capture economy of scale. For example, if there is a fixed cost with placing an order, transportation, or receiving an order, or it could also be incentivized through quantity discounts. So if we look at this figure, so say this curve is demand, and we say we fix the production lead time to be order lead time to be 5 weeks, order interval to be 5 weeks. So we order every 5 weeks. So then we'll add up the total demand during the next 5 weeks. So the total effect is we have these large peaks in every 5 weeks and then nothing in between. So this will translate to much higher variability if it's seen from the supplier of this company. And if we have, if this is a firm with multiple products and they're syncing the ordering of different products, this batching effect will be even more pronounced. And then when there is a large replenishment lead time, this operational obstacle is also more pronounced. So remember when we generate orders based on demand forecast of the immediate downstream stage, we'll tend to interpret, say, the last few data points as a trend, right? And then we interpolate this trend to forecast for the next few periods. And the longer the lead time, the more we need to forecast into the future. So if lead time is this much compared to lead time is this much, so L2, we're going to have the trend being extrapolated farther into the future. So if there is a misinterpretation of the trend, then the mistake is much higher if the lead time is longer. And I briefly explained this, the issue of rationing and shortage gaming. So this is what happens when we ration the orders based on the number of orders received. So, and then this will lead to companies to exaggerate how much they need and lead to misrepresentation of the actual demand. So pricing strategy. So pricing can refer to a single price or a menu of prices. So the pricing policy can also lead to higher variability. How so? One is in terms of a menu price, right? So we could say if you order one product, it's this much, but if you order 100, then each product is cheaper. So then this quantity discount will tend to generate large lot sizes, and large lot sizes will lead to operational obstacles and therefore lead to higher variability. The second pricing obstacle is price fluctuations. So basically, you can see it as price promotions. So in a previous chapter, we talked about using promotions or short-term discounts to induce forward buying. And that was actually used as a tool to maximize supply chain profit. But this is based on the assumption that promotion is planned really well. In contrast, if promotion is planned in the wrong places, it can have the opposite effect. So, this is a artificially generated peak in the manufacturer's demand, because the manufacturer runs a promotion during this period. Right, so running a promotion during this period will lead to the retailer to order a large quantity in this promotional period, whereas the sales actually is not that high. So behaviorally, there's also issues with learning about past mistakes. Because without coordination, without information sharing, it's impossible for each stage to understand the implications of their actions on the rest of the supply chains. So then they tend to blame the final results on each other, and without seeing that some of the consequences are actually generated by themselves. And so this will lead to a vicious cycle of one stage creating the very problems that they blame others for. And also, everybody will see the situation locally, trying to react to not meeting the immediate demand, or not getting the direct supply, rather than identifying what's the root cause of the problem. And also leading to different parties blaming one another for the fluctuation, leading to less trust and a significant duplication of effort. And then, since they don't trust each other, they are less intended to share information with each other, so no one will learn from the result of its actions over time, and the vicious cycle goes on and on. So there are some managerial levels on removing each of the previous obstacles. So including, first is aligning the goals and incentives between different stages and different functional departments of the supply chain. And making sure that each one in the supply chain is aimed at maximizing total supply chain profits. And one of the most important issues in supply chain coordination is how to design incentive mechanisms within the chain so that the goals are aligned. So, for example, Walmart will actually pays HP Hewlett Packard for each printer sold, and this will give them HP the power to make replenishment decisions while also considering the revenue generated by Walmart. And then aligning the incentives across functions. So decisions in facility, transportation, inventory should be evaluated based on their overall effect, but not just their functional costs. Pricing for coordination. So there are a lot of pricing contracts to achieve coordination, such as buyback contracts, revenue sharing contracts, quantity flexibility contract, and all of these are not a simple quantity discounts factor. Although quantity discount can make sense if the manufacturer or the supplier actually see an economy of scale. And then to deal with the sales force incentive obstacle, right, so one can simply translate the selling incentive, which means how much the sales of the manufacturers sells to the retailer, and translating to how much the retailer eventually sells to the customers. And so this will eliminate the incentive for just shifting future demand to current period and creating these artificial demand peaks. And also, sometimes this combined with a rolling horizon approach, but basically not limiting the sales to current period, but to next period and so on, in a rolling basis, will also reduce variability. So information distortion, to eliminate information processing obstacle. Of course, we want to share data. And the most important data to share between supply chain members is demand data. So in a lot of companies, a lot of supply chains, this demand information is shared throughout the chain. P&G will share their demand data with their suppliers, and they also ask Walmart to share the sales of their product with them. And then, since the bullwhip effect is also generated because forecasting is duplicated at each supply chain stage based on distorted information, then if we do the forecasting collaboratively and the planning collaboratively, that will reduce the duplication of efforts, will make sure that the forecast is more aligned, and then make sure the decision between different stages are achieving the same goals. And then the another effective tool is to eliminate control from different points. So just allowing control at a single stage, then that effectively reduces the need to collaborate. So this is achieved through either continuous replenishment programs or vendor management programs. And then improving operations. One is reducing lead time. So this can decrease the uncertainty of demand during lead time, increase forecast accuracy, and maybe sometimes if the lead time is reduced to sufficiently small, forecast need can be completely eliminated. And reduction of lead time could be a result of enabling electronic transmission of orders and sharing order plans, production, demand, supply plans between different parties, and increasing the production flexibility and using advanced shipping notices, cross-docking, which means the truck that just unloaded material will immediately be loaded material for outbound shipping. Reducing of lot sizes will decrease distortion. Right? So, because large lot sizes are generally generated because of fixed costs, so if we can eliminate these fixed costs, then that will significantly reduce lot sizes. So these would be reduce fixed costs associated with placing an order, transportation of an order, and receiving an order. Now, to eliminate gaming in ordering decisions, we can change the rationing strategy from rationing based on based on order quantity to rationing based on past sales. Right, so then in this strategy, no one will have an incentive to exaggerate their orders. And also it gives them this additional incentive to sell more during this period so that in the future they can receive more allocation. So, and designing pricing and promotion strategies to encourage smaller lot sizes and reduce forward buying. So one of the incentives of large lot sizes is quantity discount. Right, so rather than saying, okay, if you place an order of size so such and such, I'll give you a discount, one can say if during the whole quarter, if you order sufficiently, then I'll provide you a volume discount. So then that removes the incentive to order in large sizes each order. And then stabilizing pricing will reduce the impact on forward buying and results in orders that actually matches with the demand. So it also reduces information distortion. So finally, building strategic partnerships and trusts. So this is more of a soft issue, and it's complicated, and so basically the idea is if there's trust, it will be easier to coordinate, and if there is more coordination, it's easier to trust each other. So that tend to formulate a virtuous cycle. And also when there is trust and coordination, well, if supply chain parties trust each other, then the previous levers we talked about are also easier to achieve. One thing that's critical to build trust is to share accurate information. And that will also lead to immediately improve the results, because then we can better match supply with demand. And then a better relationship also tend to lower transaction costs between stages and also reduce duplicated efforts. So, for example, if we coordinate, or if the supplier actually trusts the forecast or the demand information provided by the retailer, then there is no need to generate forecast again. And then all the parties must believe that the benefits of this coordination are shared equally. And generally, a high level of trust will allow a supply chain to become more responsive at lower cost, and actions such as sharing information, changing of incentives, will typically help improve the level of trust. Some practical approaches. Previously, we briefly mentioned this single point replenishment strategy. So one is the continuous replenishment program, in which we have either a wholesaler or a manufacturer making replenishment decisions on behalf of the retailer. And this decision is based on point of sales data or the inventory dynamic data at the retailer store. So generally, the decision based on the actual inventory information is easier than point of sales data. One, because they're easier for the retailer to be willing to share, and the other one, that's what we're actually directly using inventory ordering decision on. So in CRP, the inventory is actually owned by the retailer. It's just the management is outsourced to the wholesaler or the manufacturer or a third-party logistic company. And vendor managed inventory is very similar in the sense that it's also a manufacturer or a supplier managing the inventory for the retailer. The difference is that here in VMI, the inventory is owned by the supplier, until it's sold by the retailer. So the retailer actually doesn't own this inventory. And another one drawback of VMI or CRP is the issue of substitution between different products. Okay, so if we have a large retail store such as Walmart, they often, under each product category, they often carry different products, often from competitor brands. Right, so so for Walmart, a shampoo may be from P&G or some other brand like Unilever. Right, so if Walmart give both P&G and Unilever the authority to manage their respective inventory, then they would know the demand or the inventory information of the other guys, right? So because the products are highly substitutable, then the inventory or demand of one product is going to impact the demand or inventory of the other product. So that could lead to questionable inventory management if the replenishment of these products are treated independently. So in these cases, the retailer could actually be a better source to manage the inventory. In some occasions, we actually have a category leader to manage the inventory of the whole category. So, for example, for shampoo, Walmart may ask, P&G to manage all the shampoos from different brands. Then in practical coordination, we often need to do collaborative planning, forecasting, and replenishments. So, and these activities are done along any of these following horizons. One is on strategy and planning. So in this, the collaboration is to define the strategy of the collaboration. So for example, the scope of collaboration, right? What roles each company would play in this collaboration, what are their responsibilities, and when are they going to be checked for their performances. And so for example, in a joint plan, they can identify some significant events like price promotions, introducing new products, and store opening and closing that affect demand and supply. Then, along demand and supply management, we collaboratively generate sales forecast for along different members of the supply chain. And this is then converted to a collaborative order plan to determine the future orders and delivery requirements based on its forecast. Then we have execution, so converting the plan to actual orders. So this conversion involves the shipping, production, receiving, and inventory holding. And finally, analysis. So in this part, in analysis, we tend to focus on identifying exceptions and developing metrics for evaluating our performances or identify any trends in the performance. Some common CPFR scenarios, right? So different levels of collaboration. One is collaboration on retail events. So, for example, in planning promotions, right, which requires different parties that are collaborating to identify, okay, which brands do we need to promote and what specific SKUs are included in the promotion, and to determine the promotion, we need to determine the timing of promotion, how long the promotion is going to last for. Do we want to implement any advertising efforts and display tactics and so on and so forth, and how big is the promotion? And then on the DC level, we may have different parties in the supply chain to collaborate to determine the replenishment decisions from distribution centers. So this may involve parties to collaboratively forecast for the DC inventory withdrawals and anticipate demand from the DC to the manufacturer. And then for store replenishment decisions, we can also collaborate to generate store level forecasts on their point of sales. And they are then converted to a series of store level orders and for a specified time horizon. And the last one, collaborative assortment planning, is more for industries with seasonal demand. So this is very common in fashion industry. So the fashion designers and manufacturers and retailers will collaborate on interpreting industry trends and using a combination of these trends and customer tastes and macroeconomic factors to forecast what is going to sell in the next season. And then this is translated to manufacturing orders, design inputs, and then store replenishment decisions. And so other than these points, we need to pay attention to the organizational requirements and technology requirements for successful implementation of CPFR. So, for example, on organizational structure-wise, it's often more effective to establish these cross-functional teams to enable collaboration. So, for example, on the manufacturer side, we may set up these cross-functional teams that focus on large customers. Right? So maybe this is P&G, and this is the collaboration team focusing on demand from Walmart. This is demand from Meijer, and so on. And these teams will include functions in demand planning, logistics, and sales. For the retailer, we also need to generate these dedicated teams, sometimes for individual suppliers. So if the supplier is large enough, a lot of times we for a retailer we may have many different suppliers. So then we, instead of having dedicated team for each single supplier, we'll have these category teams, right? So for shampoo, we have a whole team dedicated to figuring out the strategies for merchandising, planning, and purchasing and replenishment. And additionally, within implementing CPFR, we may also see risks of information misuse. So, for example, this is more of a concern when there is collaboration between competitors in the same category. And another risk is for, if during the collaboration, one of the partners decide to completely change their strategy or scale or technology, that in order for the collaboration to work, the other parties in the collaboration will also need to adapt accordingly. So oftentimes these collaborations will require very close interactions between companies whose cultures may be very different. So, in practice, it's often best to start with high-level collaborations, either based on events or based on collaboration at DC level or higher level. And lastly, to achieve coordination in practice, the first step is generally to quantify what if we don't have collaboration, what is the impact on our supply chain. So that is helpful to raise awareness of the importance of collaboration between different stages. And top management commitment is very important to guarantee the resources are in place to enable collaboration. And we focus on communications with between different stages. And one of the best ways to solve communication issues is to establish these cross-functional teams that's composed of staff or workers from different companies. And the full benefit of the coordination is achieved only when the entire supply network is coordinated. However, it's often very, very challenging to achieve. And technology is helpful to improve connectivity and collaborations. So it's important when a company invests in significant technologies such as the ERP system, it's important to understand that these systems can facilitate collaborative forecasting and planning across the supply chain. And of course, nowadays, the internet is a standard approach to share information. And then, lastly, one of the biggest hurdles to achieve supply chain coordination is different parties in the supply chain believing that they are not fairly treated. Right? So it's really important to make sure that the benefit of the whole coordination is shared fairly and equally between different parties. And this equality perception is shared by everybody. Okay, so that's it for today.